All right. Hello, everyone. Uh, so I'm putting together a quick video here uh, for anybody that wants to get familiar with Python, but hasn't really done the research yet. So this is going to kind of take you through the process of getting started from scratch, so that you have the basics of how to get it installed, how to create a few programs, and then some of the basics of how it works, some of the syntax, what it can do, what it can't do. So we're going to go through real quick. This is on a Windows machine. If you're using Linux or if you're using Apple, I think Apple comes automatically with Python 2 already installed. Linux has Python 2, Python 3 already installed by default. But if you have a Windows machine, it may not be guaranteed that you already have it. So in this scenario, we're going to go through from scratch on a Windows machine. You can go to the website python.org, and you can simply go to downloads. Again, you can see all the different platforms you have. Specifically, in this case, we're going to be looking at Python 3, or the different versions. So the latest release of Python 3 is 3.10. Python 2 is a similar language, but it's a little bit more outdated. A lot more functionality exists in Python 3, and although the syntax is similar between the two of them, there are certain commands that if you try to run them in Python 2 and Python 3, they're not compatible. So they are basically two different programming languages, even though they have the same name. So in this case, we're just going to grab the latest version of Python 3. So I do have Python already on this computer. So let me pull up my command prompt. And what you can see here is if I just type Python, I can actually get a prompt there showing that it's already installed. Or you can do Python -- version and see what version of Python is already installed. But in this case, I'm going to go through the steps of how to install it. So based off of what you're trying to install here, you can, get a compressed file if you want an embedded package, or 32-bit or 64-bit. They have the installer. Again, this is the recommended version, so I'll go ahead and download the installer. And once it's complete, it should kick off a basic window. You'll need admin permissions to do this. And one key thing you probably want to do to save yourself some time on Windows is add a path to Python 3. Whichever version, 3.x, so that when you type in Python automatically, it'll pick up what you're looking for when you say Python. It'll figure out what you mean when you type it in command prompt or using an editor. If you don't have the path, you have to take an additional step to manually go in and add that path. So I'll go ahead and just install now. And it's a pretty basic install wizard. If you've installed anything else on a Windows machine before, you've seen something similar. But it also provides you a couple other options as you're installing. So we'll give it a few minutes here. All right, while that was installing, I went ahead and just paused. It's completed now. So we'll continue on with the demonstration. So Python will now be installed on my computer. Again, it was previously installed. And again, it was the same exact version, so we won't see any difference here. However, if you wanted to go ahead, if you're following along, if you didn't have Python installed previously, you followed the same steps. Now, when you would do Python version in your command prompt, you would see the latest version you just installed. So it's that easy to get started. Once you have it installed, you can create a prompt, an interpreter within the command prompt itself, just by typing Python. And I can actually make Python commands right in the terminal. For example, if I just type 5, it's going to repeat back 5 because it doesn't necessarily know what to do. But I can save it into a variable and say x equals 5. Didn't really show anything there, but now if I type x, you can see that it has 5 stored into it. I can say x plus 6. You can do anything in there. You can also do variables. One thing with Python is you're not stuck with a specific type once you've set a variable. So I can just say x equals hello, and then I can do the same thing and just type x, and you see it prints out hello. So it's not going to give you an error for that. And sometimes that's helpful. Sometimes it also can hurt. Now, doing it all in the terminal is one thing. However, the real power of Python comes in where you create a Python file, a .py file, .py. And there's a couple of different editors that you can use for that. There's Atom, there's Idle, but the one I prefer to use is Visual Studio Code, which you can download for free. In addition to Python, it also supports Java, C++, C#, all the main programming languages, all in one editor. So it's one that I really like to use. You can go to the site. It's pretty lightweight. Again, you can download it for Windows. I have it downloaded already. So I'm actually going to just open it up. And you see something like this when you pull it up, a getting started page. You don't necessarily need to care about what's on there, so you can close that. But what I will do is I'll open a folder. So I went to File, Open Folder, and selected this folder I'm in currently. And what it allows me to do is add all types of files just by hitting this plus sign. I can add a new folder, but in this case, I'm just adding a file. And I'm going to call it demo.py. You can create any other type of files as well, like test.txt, and it creates a text file. But when you have Visual Studio Code installed, one other thing that I would suggest is to go over into the extensions. There's a couple of good Python extensions. You can search for some of them, but Pylance and Python, it provides IntelliSense. Basically, it'll parse your file and identify if something's a variable, if it's a definition or function, if it's a class, and it'll provide some color coding to that to make it a little bit easier. It'll give you some preemptive errors checking. So I suggest you try to do that and install the Python extension. But once you have the Python file, again, it's pretty straightforward. You can do the same thing that we did before. So here, I wanted to say x equals 5. Now I hit Control S to save, and I'm going to open up a terminal here. Again, one of the great things about Visual Studio Code is it has a built-in terminal. You can use PowerShell, Bash, command prompt, any other type of terminal that you would like to support. So in this case, I just have a PowerShell, and I can run this command now, this Python file we created, and just type Python and demo.py. Now you're not seeing it doing anything, just because in contrast to running it in the terminal, you're not going to see input right away. So if I wanted to actually see what that result is for X, I could use something like a print statement. And then down here in the terminal, you'll see that we have the output. It just prints out 5. And then just like before, we can do x plus 3. Now, again, if I just do this, you'll see it just print out 5 because I didn't actually change the value of x. So x equals x plus 3. Now, if I run that one, you see that we get 8. So one thing with Python is that it is formatted based off of indentation. So for syntax. So if I do something and I put in an extra space here, it's going to give me an error. And this is at IntelliSense telling me that something is wrong. Everything must be lined up with the lines above it unless it's a nested object. So a loop or a definition function, in other words. A class, you can have stuff inside of a class. So anything inside of one of those objects is basically a subset of code. So for example, if I wanted to have a for loop in Python, I could do something like this. For I, again, any type of variable I want it, in range, so from 0 to 5. So at this point, I would just put in a colon at the end, and you can see that it took me in an indented space here. So now it'll execute the code inside of this for loop annotated by this indented space. And I can just say print. And then as soon as I go back to the left-hand side, I'm outside of the loop. And you can see that it printed 0, 1, 2, 3, 4, and then finally out of the loop. You can build all the stuff you want automatically within Python, but there's a lot of great libraries out there that already exist and do some functionality for you. And to have access to those, for a lot of them that come built into Python, all you have to do is use an import statement. So for example, there's a good library for doing hashing called hashlib, hash library. And if I do hashlib, then I could do something like, let's say I create a variable with some message. Now, you can create an instance. So Python, by its nature, is not object-oriented, but you can use it as an object-oriented programming language and kind of create classes and objects and create instances of classes or objects that you've created. So one thing I'm going to do here is I'm going to create an object and call it hasher. And I'm going to initialize it by calling the hashlib dot SHA-256. So it's basically creating using the hashlib dot SHA-256 class and creating an instance of that and storing it in this hasher object. Then I can create another variable. I'll call that variable hash message. And what I'll do is I'm going to take my message and encode it. So when you're using hashes, it needs to be encoded into bytes in order for it to perform the hashing. So I'll do hash.encode. And I'm just going to use UTF-8. And then once I do that, now I can say hasher, again, my object up here, hasher.update, and I'm going to update it with a buffer. So basically what section of bytes I've created, and it's going to be the size of whatever this encoded message is. I'm going to say hash message. From there, that's basically performing the SHA-256 hash on there. And I can actually get the values by using something called, hasher, our object. And I can get its hex digest, which is, an easy to read format. And I can store that into a variable. I can do the same thing and get the bytes. Just by using digest. So with all this stuff, if I wanted to actually see what I was producing at each of the times, I can print hash message, just some informal debugging. Here I can print what the hex digest is. And down here I can print what the byte digest is. And if I run the code again, I have a spelling error here. Digest. And you'll see that, so this first print message is our hash message. So it's basically taking our message, which is hello, and creating it as a byte format. So you can see here that it has the little B in front to indicate that it's bytes for the string hello. The next print is this one here, which is the hex digest. So it's basically the hexadecimal representation of the hash, and then the next one is again the binary, or the bytes associated with that digest. With print, one thing you can do is actually have multiple items printed out at the same time. So I could do something like this. So have a string first, and then put a comma, and then whatever variable. Do the same thing down here. I can have whatever I want to call it. Doesn't need to be capitalized, but I'm just using it to help it stand out. And if I run it again, and one thing you'll notice using the hash, the values have not changed because a hash is a fingerprint of some object that you've ran through the hashing function. So you can see now we have hex digest printed, and then a little bit of a space, and then the actual hex digest. Other things you can do in Python, other than a simple variable, you can store objects as a list. So you can create a list like my list, and you just define an empty list by the open and close brackets, square brackets. And then from there you can have my list dot append, so adding things into the list. And let's say I want to add in the letter A, and then I want to add B. So adding 4. So I want to highlight this here. So after each of these, I'm going to print off what the value is. All right, we can see what we have. So we can see it's surrounded in brackets. We got A, B. First version is just A, then it's got A and B, and it's got A, B, and 4. So here, you don't need the same types of objects or same type of data stored into a list. You can have any type you want. You can even have complex objects. So a list, again, is just kind of like an array, except it's not defined by a specific type. You can have also a dictionary. So and you define that with curly brackets. And the easiest way for updating a dictionary is by just putting key. So dictionaries are key value pairs. So you need a string to identify what the key is, and then you can set a value. And it doesn't matter what the key is, as long as it's a unique key. Here at this point, I'll print out my dictionary. So after we've added 2 items to the dictionary, and then I'm going to do one other thing, and I'm going to update the same item with this key value and make it like that. So if we run the code, you can, oh, I didn't print it the second time. So we can see here the first time, item 1, and then its value is 1. And then the next item is the second key, and it has a value of hello. In this case, the second time we print, again, we haven't changed item 1, so that stays the same, but next item gets updated to world. And then we can, create all kinds of different objects, and we can add those objects in the dictionary into a list, and so on and so forth. The dictionaries are great because they tie in with the JSON format, so we can easily, let me import the JSON library. Again, one of the standard ones that come in. And if I go ahead and take my object, I can say, let's say I want to create a string object, and I'm going to use JSON.dumps. So a dump into a string of my dictionary. And then I'm going to use one of the commands that we can to open files on the operating system. So I'll just create a variable called my file equals so use open, and then in this case, if we're going to, we give it the file name. If the file doesn't exist, it'll create it. So I'm going to call this my file.txt. Actually, I'm going to do it as JSON, so I'm going to do .json. We use W to indicate that we're going to use it into write mode. Let's say my file.write, and we're going to write in the string object. And then since we opened it, right now, if we run that, we should see so we created this myfile.json, and as you can see, it includes our JSON object. Just like we can write stuff, we can do the same thing. My file equals open. We're going to open the same thing, myfile.json. But this time we're going to read it. So with R, I'm going to say the content of the file is equal to my file.read. So it's going to read everything in the file. Then, of course, because we opened the file, we need to close it. And then finally, we'll say my object is equal to JSON.load string content. So before I do that, I'm going to do print again, just to make it easy to see what we have here, content, and then print. All right, we'll run this all again. You can see it's the only difference here is that when it's just the string content pulled from the file, it uses a double set of quotes here. But if it's the actual object representation, it uses a single set of quotes. And you might run into issues with some compatibility, depending on if it treats it as an actual object or a string representation of JSON, to determine whether you can interact with it. You know, since this is an actual object now, I can say so I can say I want to print. Actually, I won't print it right away. I'll just say a value is equal to my object and then the key. So in this case, I'm referencing the item at next item, which should be world, storing it in the value, and then I'm going to print out value. So at the very end, you can see where it printed out world. If I try to do that just as the content, the JSON value, we'll notice that it's actually going to throw an error here. The string indices must be integers. So basically, it's saying that a string doesn't have an index or a key value that you can reference like an object does. So that might be an error you'll see if you don't convert it to JSON first, or convert it to an object from JSON. If you don't want to do that, if you're doing some debugging, but you don't want to necessarily delete your code, you can add a comment with the hash symbol, £, and then it'll just skip that line of code. Other things that you can do in Python, so you can actually create a method or definition. So you do that with def my function. Again, the name of the function doesn't matter. You can pass in a variable if you wanted. So in this case, I'm going to call it var1. It doesn't matter what the name is or the type. Again, you can see I'm indented in because I'm have the colon. And all this is going to do is say print var1. And then I'm going to say return, just to have it return something else. You don't need a function to return anything, but you can. And then from here, I'm just going to call my function, pass in whatever I want for the variable, and I can put in 72. And because I'm returning something, I can set it into another variable. You can see that once we called my function with 72, it went into here. So this is the value 72 now. It printed 72. It returned testing. So when we returned, it stored it into here. And when we printed that, it printed testing. You can also create a class. and you do that. This is where I get into saying that Python can be object oriented. So you can actually go and create your own custom classes. And the syntax for this, so you'll use the keyword class, then you can give the class a name. And you don't need my in front. I just do that to make it easy. You're gonna make it a colon, so everything from this point down until you exit to the left is part of the class. And it has a special function called init, so it has 2 underscores in it, and then a special variable called self, so that it just references the items contained within the class. And you can initialize it and say x equals 10, y equals hello, and I don't know, c equals and then you can create an instance of the class. So in this case, it doesn't take any other additional parameters other than self, so we can leave that empty. And now I can say, I want to print my class dot x. That's right. What are you? Sorry, it should be self.x. So that's why I passed that self variable. So if you're going to reference it for that object itself, you can see we can now print out this implementation of x. So now if I wanted to take in a x, y, and z value, so 4 for my x, 0, and then test. I don't know, whatever variables I want. I can do the same thing, and oh, I didn't save there. I think. So now I'm creating my class. Oh, and instead of setting it to x, I'll be equals x. So assigning it to the variables I pass it. So that's the very basics of getting started with Python. So hopefully this was helpful. I'm going to do more advanced videos and go into a little bit more details as we go along. But feel free to download Python, get started playing around with it, and there'll be more videos coming soon.
Good news, everyone.
That's right. Good news, everyone. This is Doc here. Made it to the end of the video, which means you liked it. So please click on the thumbs up below the video. If you have any comments, anything else you'd like me to see put a video together for, leave a comment, ask any questions. And of course, more videos like this are coming, so be sure to subscribe.